Okay, sit down, please.
That-
Hello,
That's
Mr. Eric. Hello, Mr. Ryan.
Hello, Mr.
Teacher, this is Mr. Teacher.
Mr. Teacher.
Okay, sit down, please. So today we'll talk about. Remember yesterday we talked about the binary numbers. Yeah, binary. how to
No, interval.
Oh, interval. Okay.
Yeah,
2 days ago we talked about binary numbers. Yes.
Yeah.
Binary numbers 0 and 1, right?
Yeah.
Yeah. So if you want to write 15, you have to do this 1 1 1 1, right? This is 15 in binary, right? So you can imagine if it's a big number, you should take lots of the 1 and 0, right? Yes.
Yeah.
Because we have only 2 digits to represent the numbers. So for example, like 255 in decimal is 3 digits, but if we are using the binary, that would be 8 ones. Yeah. How do I know? Because 2 to the power of 8. What's that? 2 times 2 times 2 times 2 equals
16.
16 times 16, 256, right?
Yeah.
Yeah, 256. So 2 to the power of 8. So that will be 2 to the power of 8. It means 1 in binary. That will be 80. Yeah, yeah. If I subtract 1 minus 1 minus 1, that will become 255. If I minus 1 from this binary, that will be 1 1 1 1 1 1 1. Oh, okay. Oh, there is missing 1 1. So that will be 8 ones. So that's 255. Do you get it? Yes. Okay. So now, remember, I think last time we're missing implementation of to convert this decimal into binary. For example, if I want to convert this 15 into binary, that will be 1 1 1 1, right? So how do we do that? We can just write it. Define. Remember, we divide it by 2. Yeah. Equals 7. Remember 1. Yeah. 3. Remember remaining 1. 1 remaining 1, and divided by 2. Continue until the divisor is 0. Yeah. And then we write it down this way. Right? Yes.
Yes.
Yes. Okay. So now define. Let's call it decimal to binary. So that's n. Okay. So now we put it in answer as a empty string. Yeah. Empty string. Now what should we do? Y. N is bigger than 0. Right. Now then we can answer equals. We need to make it as a star, right? Star n divide n remaining 2. Yeah, n remaining 2 plus answer.
Why do I need to be a star?
Make it converting this star function. Good question. Star function make an integer into a string. Yeah, into a string. Yeah. So this is
STR is star.
str string, short for star. It makes an integer into a string, a quote. Yeah, a string. This is number. This is string. Different types. Yeah. So now look. This is getting the remainder. Remember 1 1 1 1. Getting the remainder into a string and plus itself. So we connect it in the reverse order. And then now n is n divided by 2, right? Right? And then return answer. This is the way to basically to convert the decimal into binary. Remember this, yeah? This is very useful. Now today we are going to talk about hexadecimal. 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 I probably not how you write it, but hexadecimal. What does it mean? Hex.
Hexagon.
Hexagon. What's hexagon?
Hexagon.
6 sides, yeah? Okay, good question. This is 6. Yeah?
Yeah.
This is 10. So how many altogether?
16.
16. Yeah, well done. So hexadecimal is 16. So we're using 16 kind of different character to represent the number. So can you guess what are the tens? So we have 0 to 9, they are 10, right?
Yeah.
And then what's next? What's next?
0.
Can you guess what's after 0 to 9? What's after 0 to 9?
10.
No, there's no 10. 10 is 1 0. So we're using A, yeah? B, C,
Yeah.
D,
E, F,
E.
G, H,
F.
I, J, K,
That's
L,
it.
M, N, P.
2, 4, 6. Yeah?
2, 4, 6.
So we use these.
8, 10.
This is
12,
10.
14,
This is 6. We use these 16 kind of characters to represent the numbers. So it's shorter. Yeah?
16, 19,
Do you understand?
Yeah.
So can you tell me what's
14, 15, 19,
Okay.
20.
wait. Can you tell me what's A in decimal?
Wait. What?
What?
A in decimal.
What's 9? 9 is 9. What's after 9?
10.
Yeah, 10.
11.
This is 10, okay? How about F? What's F?
16.
No, close, very close.
9, 10.
10 is B. What's this? 11?
12 and 14.
14 is E. What's F?
15.
Well done. Okay, what's 16? What's after F? What's 16?
G. 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 G.
No, there's no G because we already have this. Remember, after 9 is 10, yeah?
Hey. Hey.
No, that's not H.
I. 10.
Yes, well done. Yes, well done. 10. This in hexadecimal is 16. Look, it equals 1 times 16 times 1, yeah?
Yeah.
Plus 0, okay?
Yeah.
So you see it's similar, yeah?
Yeah.
It's similar. Okay, so it's similar. So let's say, okay, I give you another one, okay? How about
Oh,
How about 100 in hexadecimal is how many in decimal?
10.
In decimal, this is hexadecimal is in what? Remember how 1 times 16, 1, 2 plus 0 plus 0. So what's this?
256.
Yes, well done. Yeah, you see?
Yeah.
Yeah. How about this in binary? How about this in binary? What's that? 100 in binary. What's that?
100 in binary. 100 in binary. 4.
Yes, well done.
4. Yeah.
Yes.
Oh, yeah. Oh,
So you
yeah.
get it, yeah? How about 100 in decimal is what?
Decimal is.
That's easy, yeah?
I'm not sure.
100 in decimal
What
is 100. Okay, come on.
What?
Yeah? You
Yeah.
see? Because it's 1 is 10 to the power of 2,
They
right?
add it all up together.
So basically, you just need to this is digit times the base. Yeah? There are two positions after that. That will be 2, yeah? Okay? Don't sing, please. It's too noisy. Okay. So how about now so let's write it. Let's write this hex to decimal, okay? Define hex to decimal. It's similar to binary to decimal, right? Yeah?
Yeah.
Okay, let's do it H, okay? So now we got the answer, yeah? Answer equals 0, okay?
Answer
Now for I in
in the
H, answer equals answer times what? Times what? 16. Because we are moving, remember, if it's a decimal, we move one position to the left is times 10. If it's a binary, it's times 2. If it's decimal, it's times what?
10.
No,
16.
16.
Oh,
Plus, we need to map, look, we need to map this I to the value. So we use the mapping. Mapping, let's do it map first, okay? And then return I, right? Return answer, yeah? Return answer, but this M, good question. This M is a dictionary. So let's just do it this way. Look, we can just write here M. Okay, this is gone. This is bad.
Gone.
Okay, so this M we can define as a dictionary. Remember? Dictionary, yeah? Dictionary. So this I, what kind of possibility does this I have? In hexadecimal, it could be 0 to 9 and A to E, A to F, right?
What's F?
No,
What
F,
D,
look,
what
A
D,
to
what
F,
I,
look.
what D,
So it's 0, we map into 0, right? And then 1 mapping to 1, and etc. 9 mapping to 9, and then A mapping to 10, right? B mapping to 11. You get what I mean? Yeah?
That looks like 13.
Yeah. So another thing is this could be lowercase as well. So instead of doing this lowercase and uppercase, we just do this I dot upper. Yeah, I dot upper means to change this to uppercase. So A will become A, right? And A is still A, right? And if it's one number, it doesn't have any impact, right? So we have this mapping 0 to 0, 1 to 1, A to 10, B, C, D, E, F, F to 15, right? And then we'll look it up, yeah? It's quite similar. If in binary, what's in binary? Binary, remember, the binary to decimal, we just change this to 2, right? Yes? And then, and what? And plus I could be 0 and 1. So in binary, that would be integer. I, just integer I, yeah? Yeah, it's okay, so this is
Why do you keep looking at me, not Ryan?
Ryan, Ryan, I look at you, okay? You are here.
Why don't you not look at Eric then?
Okay, I look at you both, okay? Now,
Before you're just looking at me.
okay, so now what's the next part? We convert backwards from hexadecimal to binary, or to decimal. So let's no. From decimal to hexadecimal. So we want to if it is 255, okay? So it's the same. Let's look. What's this in hexadecimal? Let's divide it by 16, okay? Let's divide it.
16.
Oh no.
15. Remain 15.
No.
What?
Look.
You
This
just
250.
You got the lid.
Yeah, I know. 255. This is decimal. The number we talk about. We want to convert it to hexadecimal, okay? Okay? 16, base 16. We call it base
So
or
the first
base
is
16.
like this shape.
So first of all, we need to divide it by 16.
Yes, 15 remain 15.
15? Is it 15?
50 remain 15.
Really? I'm not sure. How do you know? 16, 1, 16. That's 9. 5. 5, 90. 5. 15 remaining 5, right? No? No. Oh, 15. 15, yeah.
Yeah, I told you so.
Oh, 15 remaining 15 and divided by 16. What's that? 0 remaining 15. Okay, so we write it this way, yeah?
Yeah.
So 15 in hexadecimal is what?
5151.
No. In hexadecimal.
1515.
F. Remember, F is 15, right? A is 10.
Oh yeah.
And then this 255 is equals FF in 16. Got it? Let's try another number. Okay, is this still good? Yeah. Let's try this. Let's try this. 108 in 16 in base 16.
Base 16.
Ryan, divided by 16 equals what?
Equals
6 remaining 12, right? Is it? 108.
Wait.
6.
It remains 4.
No. 696. There will be 12. So remaining 12, right? And divided by 16. That's 0 remaining 6, right? So 6.
4.
Some of 4.
16.
Let remaining 12.
Oh.
12. What's 12 in hexadecimal? A, B, C. Which number? 12. Which is
3.
10, 11, C. Okay. So this is 6C. Okay. So let's write it the other way around. This thing equals what? What in decimal?
Hex in decimal
6C 16 equals what?
equals hexagon.
Let's write 6 times 16 plus C. C is 12. So let's look. You see? Let's the other way around, right? Yeah?
Yeah.
You got it, okay? Okay, so now we want to write the program. Define decimum to hexadecimal. Okay? So let's end. Come on. Remember what we have to talk about?
Mapping.
Answer equals this, yeah? Well, look, y n is bigger than 0.
Talk about mapping.
Yeah, I will talk about the mapping before later. Okay, and answer equals answer plus. No, not plus. We call the mapping first. Yeah, mapping n plus answer. Yeah, answer, and then return answer. That's it. Oh no, and n divided equals 16, right? Yeah, but this needs to n modulo 16. Okay, return answer. So this is basically the same as the binary, but look at this. M is a mapping.
We need the mapping.
Mapping this. How many possibilities of n modulo 16? How many possibilities? 16. Yeah. How many possibilities of n modulo 2?
2.
Yeah, exactly. So we need a 16. 16. So mapping equals what? 0. That will be 0, right? 1, 2, 3, 4, 5, 9. But now 10 will remain. 10 will be A, right? Listen.
I am.
Okay, 11. What's this?
11.
What's next?
B.
B, yes, B. Okay. Okay, and then F. So 15 is what? Yeah, well done. So okay, we got a mapping. What's the time complexity?
1. O-N. O-1.
No.
O-N.
No.
O-double. O-log-N. O-N.
A little bit. No, you're not just guessing because each number is n. Every time we divide it by 16, right?
Yeah.
Yeah, every time we divide it by 16.
Yeah.
So how many 16? You could be log 16 base n, right? Yeah. So it's like binary is log n. If I tell you a number n, I want to convert it to binary, then it takes log n, right?
Yeah.
Yeah, because that's in base 2, log n. Log n, when we talk about log n, is base 2. Okay, it's base 2, yes? But this is 16, every time we divide it by 16, so it's log 16 base n, okay?
Where's the base?
Base, this is base. Look, remember this log xy equals a. Do you understand? This is actually, you can write it as x to the power of a equals y, right? Yeah? Remember, log 2 to the power of a, log 2a equals what? Remember this, equals 3. Because 2 to the power of 3 equals a. That's why we write log 2 to the power, to the log base 2, a is 3. Okay?
Yes!
No
questions.
So what have we talked about today?
We talked about hexadecimal.
Hexadecimal. Okay, so one last question.
No questions.
One last question.
No questions.
What's
What?
1a 16 equals
Then.
what's decimal? What's this number? And another one. I want it another one.
You said what? Just
Okay, just one. Okay, what's this?
Okay. So that.
What's this?
1.
1 times.
10.
No, I'm talking about 16.
1 times
16 to the power 1, yeah? Plus a.
Yeah.
So what's this number?
Okay.
16 plus what's this?
10. 26.
26, okay? Yes, got it? Okay, good job today.
Nani.